For Chapter 6, we're going to be looking at normal distributions. I'm going to cover 6.2 first, and I'm doing this out of order for a reason. It just helps us understand 6.2 and then go to 6.1. So your objectives here are going to be interpret graphs of normal probability distributions, find areas under the normal curve, and find x values for given areas. In Chapter 5, we did discuss random variables that had discrete countable values. And in Chapter 6, we're going to be discussing the normal distribution, which is one of many continuous random variable distributions. So when you're thinking about continuous, remember that means infinitely many values. We don't usually know parameters, but let's suppose a magical pig fairy tells you that at birth American Yorkshire pigs' weights are bell-shaped, has a mean of 48.0 ounces and a standard deviation of 8 ounces. Which would be more surprising, a piglet with a birth weight of 46.2 ounces or a piglet with a birth weight of 59.4 ounces? So to answer this, we could convert each weight to z-scores and say that the furthest from the mean is more surprising, or we could calculate the probability of seeing a piglet with a weight of at least as extreme as these and compare the probabilities. We will be doing that second approach in this chapter. So we are going to be looking at probabilities and comparing those. A normal distribution is a continuous probability distribution for a random variable x, historically a very important distribution in statistics. The graph of our normal distribution is called the normal curve, and you can see a picture there below. Some properties of a normal distribution. So the mean, median, and mode are all equal. The normal curve is bell-shaped and is symmetric about the mean. The total area under the normal curve is equal to 1. The normal curve approaches but never touches the x-axis as it extends further and further away from the mean. So what that is just meaning is these tails here never actually touch the x-axis. They just get closer and closer and closer. So we will be using a new formula in Excel. It is equals norm.dist. And then you'll have your x value, your mean, your standard deviation, and true. So this is the formula that gives the probability of that a random observation will be less than x. Now pay attention here. I have less than x, and that is because Excel will only calculate values left to right. So if we have to find something that's greater than, there's a little more we have to do, and I'll be showing you guys some examples in just a minute. Now we will always use true at the end of norm.dist. You may also see a number 1 there in some of the notes, so if you see a 1 or true, they are the same thing. So looking back at that American Yorkshire pig weights, we have that they're bell-shaped. The mean is 48.0 ounces and the standard deviation is 8 ounces. If I wanted to find that the pig weighs 46.2 ounces or less, then I'm going to be finding the probability of x is less than 46.2. And my formula then would be norm.dist, parentheses, that x value that we're looking for, and then you'll have your mean, your standard deviation, and true. If I'm looking for the probability x is greater than 59.4, now again, Excel only does left to right. So you have to say, well, I'm actually looking for a greater than, so that's looking for the right side. So you have to do 1 minus norm.dist, your x value, your mean, your standard deviation, and true. Let's look at an example for Labrador puppies. So we have Labrador puppy weights that are bell-shaped. It has a mean of 11 ounces and a standard deviation of 1.5. Suppose you're delivering puppies and you're curious about the probability that the next puppy weighs less than 10 ounces. Find the probability that x is less than 10. So the first thing that you always want to do is actually draw a bell curve and shade the area that represents this probability. I want you guys to really, on paper, draw a normal curve because this will help you with the problems. So I'm going to sketch my normal curve, and we have a mean of 11, so then 10 is going to be somewhere down here. And then you're going to say it's less than 10. So I'm going to just shade that area. Okay. Now we're going to use that and keep that image in mind as we are moving forward. So then after you draw your normal curve, you're going to put into Excel equals norm.dist 10, 11, 1.5, and true. So again, remember it's norm.dist, your x value, your mean, your standard deviation, and then true. When you put that into Excel, that is going to give you your answer. And you can see here that we get 0.2525. So what you want to think about is look at what you have shaded and look at your answer. Does this answer look reasonable based on what you shaded? And we would say yes, it looks like about 25% of the area is shaded in our graph. Again, we're looking at this shaded region here, and that looks about like 25%. So you should always start by drawing a bell curve and shading the area that you're looking for. Drawing and shading gives you a clue about what is reasonable. For example, if you shade more than half the graph, but Excel gives you a tiny probability, you may have typed something wrong and you should go back and look at the problem again. There are three kinds of probability questions: less than a value, more than a value, and between two values. And so you can see here I have them labeled less than A, more than B, and between A and B. Now, since a normal distribution is a continuous distribution, we can treat the probability that X is less than A and the probability that X is less than or equal to A the same. But this is only true for continuous random variables like normal distribution variables. So again, we can treat less than and less than or equal to the same only in normal distributions. Do not get normal distributions and your binomial distributions from chapter 5 mixed up there. So here are those Excel codes for each of those types of problems. So if I have less than A and I am looking for the probability that X is less than A, I'm going to do equals norm.dist, my A value, the mean, the standard deviation, and true. If I'm looking for more than a value, so here I have the probability X is greater than B, then I will have 1 minus norm.dist, your B value, your mean, your standard deviation, and true. If I am looking for between A and B, okay, so the probability that A is less than X is less than B, you will need to subtract the probability of the larger minus the probability of the smaller. So I'm going to do norm.dist B, mean, standard deviation, true, minus norm.dist A, your mean, your standard deviation, and true. So I would like for you guys to take time and actually try some of these problems. So I want you to find the probability that a single lab puppy selected at random will weigh less than 9 ounces, more than 12 ounces, and between 11 and 13 ounces. You can pause the video here, draw and shade first, and then get those Excel answers. And when you see the next screen, you will see those Excel formulas. So here are your answers. You can just check over. If you have any questions, you can always ask in the Unit 2 Teams channel. Sometimes you're interested in finding the X values or the data values that are associated with some probability. Your examples would be like, what puppy weight marks the bottom 5%? What is the piglet weight that is in the 90th percentile? How tall are women who are in the middle 95% of heights? So these are all finding X values rather than finding the percentages. So let's take a look at this first one. What is the puppy weight that marks the bottom 5%? So when you're looking for that bottom 5%, what you're saying is that you're looking for this percentage here because you've shaded approximately 5% there. Okay, so I'm looking for some X value. So the first thing you want to do is draw a picture of the normal curve and shade approximately 5% of the area starting from the far left. And then since we're looking at a probability that X is less than some value, okay, again, I'm looking here, I'm going to try to zoom in. Let's call this A. So I'm looking for that probability. We are going to use a Excel function that does an inverse. So it's the normal probability inverse function, norm.inv, and you'll put the probability, the mean, and then the standard deviation. So if I'm going to try to find this answer for the puppies, I'm going to do equals norm.inv, parentheses 0.05, comma, my mean of 11, and then my standard deviation of 1.5, and you should get 8.53. So what we're saying here is that Labrador puppies weighing below 8.53 ounces are in the bottom 5% of puppy weights. When you're working with norm.inv, it is going to ask for 3 inputs in this order. The probability first, so your P, and that will see an X value below the output. This is the same thing as the area to the left. Mu is the mean of the normal distribution, and sigma is the standard deviation of the normal distribution. Now remember that Excel only works with probabilities or areas to the left, so you may need to use that complement rule to find some X values if you're asked about an upper percent or something like that. So let's take a look at an example here. We have a common design principle is to accommodate for the middle 95% of a population who may use a product. For example, when designing the interior of heavy machinery, the controls should easily reach for 95% of potential operators. When designing a new bulldozer, a company wants to make sure that female operators will be able to comfortably reach all controls. If women's heights are bell-shaped with a mean of 63.7 inches and a standard deviation of 2.9 inches, what range of heights make up the middle 95% of women? You want to make sure that you first sketch a normal curve and then draw the vertical lines where approximately 95% of the middle area would be in them. And then what you're trying to figure out is how much area is to the left of the shaded area. Okay, so that's here. And then how much area is to the left of the rightmost shaded area. So that's this part, okay? So how can we do that? If 95% of the area is shaded, then 5% is left unshaded, right? That's what these two total tails should be, is a total of 5%. So then that means there's 0.025 in each of these tails, because if I'm talking about percentages, okay, 95%, if you do 100 minus 95, you get 5, and that's going to be 2.5%. So if you change that to a decimal, you have that 0.025. So then the area to the left here is going to be 0.025, and then the area to the left of this rightmost point, let's call that B, is going to be 0.975. Okay, and how am I getting that? I can just say this 0.025 minus, 100 minus 0.025, and that gives me that 97.5. And then to actually find those values, you're going to go into Excel and type in equals norm.inv, and to get this A value, okay, so that's this one here, norm.inv, parentheses 0.025, comma 63.7, comma 2.9, and you get 58.02 inches. And then to get this B area, you're going to use norm.inv 0.975, comma 63.7, comma 2.9, and you get 69.38 inches. So by height, the middle 95% of women are between about 58.0 inches and 69.4 inches tall. You can complete lab manual pages 48 to 50. And of course, your MyStatLab homework, section 6-2 at this time. And if you have any questions, please post in the Teams channel.